Welcome to physics as we are now starting our motion unit. And to start with our motion unit, I want to talk about distance versus time and that relationship. And so, to help us with this, I want us to explore it before we just start looking at formal notes or formal vocabulary. To start, I have a lab for us called the Running Man, and it is a PhET simulation and uh, well, I guess the Fed simulation is called the Moving Man, but I prefer to call it the Running Man. We will explore the relationship between distance and time, collect data, and graph the mathematical model of motion at a constant velocity. So it sounds super fancy considering we're just starting, but I promise we're gonna go through it together step by step, and then you'll see maybe that's not so scary. First, though, I want you to hypothesize, and some of you might be able to figure this out already, but hypothesize how far the man in the PhET simulation, moving at 2 meters per second, will travel if we let him walk for 6 minutes. Please do not run the simulation to test your hypothesis. Okay, so possible sentence frame. The man in the PhET simulation will travel blank meters if we let him walk for 2 minutes or for 6 minutes. Okay, so that one you kind of fill in for yourself. So really, how far will they travel? That is your hypothesis. Type it there. Then you're ready to open up the simulation. So I would go ahead and open the simulation right now. Sometimes it can take a minute to load, so don't be too frustrated if it takes a moment to load. Um, Last semester, most students were able to get it to load. There's a couple that said it didn't load at all. And so we tried again. But again, do your best and be patient, and hopefully that'll be able to load for us. So with that, you're going to open the simulation and set the velocity red at 2 meters per second. So if I open this, and this is still, there we go. Like I said, it could take a minute. I even opened it up early, and it's still loading. But there we go. Looks like it's going to work. There we go. So set the velocity for 2 meters per second. So you can use the slider, or you can just click on this box and type 2. Okay, so now you see that the slider has moved. The person is about to go in this direction, but we haven't hit play yet. Okay, so the man should be in the position of 0 meters. He will move in the positive direction. You saw that he kind of changed direction. Press the play button and let the man walk 10 meters, which is to the end of the ruler. Set the motion will be recorded, and then you can select playback, and using the step button, move the man and stop every 2 meters. When you move the person 2 meters, you're then going to record the time and distance in the data table. So you're also going to want to open this up. So if I open this Google Sheet, it's going to ask you to make a copy. Here you are. And very simple table, distance and time. The starting position is 0 meters under 0 time. So again, I'm asking you, actually, sorry, to record the distance every 2 meters. So you could pre-fill this in 2, 4, 6, 8, and I told you to stop at 10, which would be the end of the ruler. And then you're going to be recording the time. So if I hit play, there we go. I was going to say, I think it froze a little bit. And you can see again that it's recording as it's going through. So then we can hit playback, which makes it easier to stop and replay it. There it is, 10 meters, stop. You do want to make sure you hit the stop at the end of that. Okay, so then playback. Now you see I can speed it up and slow it down a little bit. So if I go right here, you can also do it by step. So if I move this person to 2 meters, I record that it was 1 second. So I come over here, that was 1 second. Now 4 meters, I'll move this person 4 meters, 2 seconds. Whoops, wrong one. So you get the idea. So you're going to record all of that data. Then I want you to create a graph. And so this program, Google Sheets, if you haven't used it, allows you to create a graph. You can highlight your data table by clicking and dragging. And then there's this insert a chart button, looks like a little bar graph. And if you do that, it might be a little weirded out since it's not a complete table. But if you do that, you can see that it plotted these data points. And so it selected scatter chart. I can actually set it to be a time versus distance line graph. And this is actually along the lines of exactly what we want. But keep in mind, once we enter all of our data, it should look a little bit different. But this is the beginning of graphing the mathematical model of the motion that we just observed. Okay, so there's a preview. Then you're going to be looking to insert a picture of your graph. So if you've never taken a selective screenshot before, I want us to try and practice that. And I believe it's Control Shift and the Windows button on a Chromebook. Okay, and I can help with that in class if need be. But once you take the screenshot, you can go Insert and Upload Picture, and that'll allow you to insert it just like this. And so that's how you'll submit your graph. This is, again, a step that we'll become better at, and some of you might be more familiar with than others, but I'm happy to help with and take as much time as needed to help with that. Okay, so now that we've made those observations, we've collected that data, we've graphed it, now let's see if we can figure out, what is this telling us about distance and time and that relationship. And so that brings us to this little slideshow, looking about how we can use this to determine predictions and make predictions about the motion. And so the formal way of talking about it is linear patterns and making predictions. So kind of a sneak peek, you're going to see that your data should form a line, a perfect line. And that is evidence that this constant velocity, our velocity was set at 2 meters per second, will be a linear pattern. So talking about that, I want to just kind of refresh. Hopefully this looks somewhat familiar from math class and when you've graphed lines, but you have y equals mx plus b. And I promise we're going to change this, but I want to make sure we understand where these equations come from when we start using them more. Okay, so in math, your y is your dependent variable, m is your slope, x is your independent variable, and b is your y-intercept. And so in science, we can determine, what is our dependent variable? What is our independent variable? And so based on this experiment and the lab we just did, we can identify those. So distance, for example, is our y dependent variable. Your distance was changing based on the amount of time. Then we had a rate, which we call our velocity. And so that was the speed or the velocity. I use speed because a lot more people have a tendency to recognize, okay, well, you're talking about, how fast something is going. Velocity is really the same thing. Okay. But so in physics, so we want to try and refer to it as velocity. So velocity is the slope, if you will, and x is the time. How many seconds in this scenario did we allow it to keep going? And then in some cases, as we move forward, your b will be the starting point of the dependent variable. And so what is your starting distance? So most of the time you'll start at 0, which means you can basically ignore it. But in some cases you're going to, like, if it's 10 meters away and then travels this far for this long, where does it end up? So you might have a starting point other than 0. So that brings us back to kind of the research question. What is the relationship between distance versus time of an object that moves at a constant velocity? That is the linear relationship. Again, we saw that in the data. And so because the data creates a perfect line, we call it a linear relationship. And again, I included the definition of velocity here. We want to become more familiar with it. The distance versus time relationship that we're talking about is this constant velocity. Okay, and so the definition, speed of something in a given direction. It is important to know that there is a direction with it. So you can have a positive velocity. You can also have a negative velocity depending on what direction you're going. And again, it says here the general use is speed. So I want us to think about, again, I promise you, we're not going to use y equals mx plus b, and then I'm going to expect that you keep remembering where these variables go. But I want you to think about, how could we use this equation to help answer our hypothesis? And so now you have the opportunity to work down here. Okay. So, and I've given you some hints to figure out how to plug it in, okay? And then I want to see if you are correct with your hypothesis. And again, it's totally fine not to be as a hypothesis. And then I want us to try and rewrite this equation using the words, the variables' names, okay? So instead of y, replace it with distance, for example. Okay, so I'm going to challenge you to do that. And then let me know if you have any questions. Please feel free to email me, and I hope to see you in class.